All right, question 8 says, consider the quadratic function f of x is equal to 2 times the quantity x minus 3 squared minus 8. And part A says, solve the equation f of x is equal to 0. That is, find the zeros of the function. All right, so to solve this equation, like we've done with a few other problems now at this point, I'm going to go ahead and replace f of x with the rule for f of x, which is 2 times the quantity x minus 3 squared minus 8, and this must equal 0. All right, so now to solve this equation, notice that x just shows up in this squared term, okay, nowhere else. So for that reason, I'm going to go ahead and isolate the square term and then use a square root. Okay, I'm not going to multiply that square out. So let's add 8 to both sides, and that gives us 2 times the quantity x minus 3 squared, and that's equal to 8 then. Divide both sides by 2. Next, and that gives us x minus 3 quantity squared on the left. 8 divided by 2 is 4 on the right. And then let's go ahead and take the square root of both sides. I'll put a plus or minus there. And then this is going to give us that x minus 3 is plus or minus 2. All right, so adding 3 to both sides, we find that x is equal to 3 plus or minus 2. And now, considering each case individually, 3 plus 2, this is 5, and if I use the minus sign, this will give us that x is 3 minus 2, which is 1, and so our solutions here are x equals 5 and 1. Okay, and as the problem mentioned, these are what are known as the zeros of the function f. Why? Well, because what we really just found here are the values of x such that if we plug them into the rule for our function, okay, I'm going to get 0 for y. So if I plug 5 in for x, I'll get 0 for y, and if I plug in 1 for x, I'll get 0 for y. Okay, so for that reason, they're called the zeros of the function. All right, now for part B, it says complete the table to the right and then sketch the graph of the function. All right, so let's do the first one here. If x is equal to 0, okay, I'm just going to plug 0 in for x. So this is going to give us 2 times the quantity 0 minus 3 squared, and then we're going to subtract 8 from that. And now 0 minus 3, that's negative 3, and then I'm squaring that. And so that's going to give us a positive 9, and that 9 will multiply the 2, and that's going to then give us an 18. And then I'm subtracting 8 from that, so that's going to give us a 10. So when x is 0, our corresponding f of x output, our y value, is 10. All right, now I've gone ahead and filled out the rest of the table as well as drawn the curve through the corresponding points over here. So when x is 1, y is 0. Oh, we saw that here, right, in part A. When x is 2, y is negative 6. When x is 3, y is negative 8. Then we get 4, negative 6, 5, 0. Again, we saw that in part A. And then lastly, 6, 10. Okay, so I've gone ahead again and plotted these points, drawn the curve through them. Now this U-shaped curve here, this is known as a parabola. Okay, and we see that our curve is symmetric about this vertical line. This line is known as the axis of symmetry for the parabola. Okay, so if I take, say, this right branch of the curve and fold it over this green axis of symmetry, right, it'll fall right over this left branch. Or put another way, okay, any point over here on the right branch is paired in a symmetric fashion with a corresponding curve over here on the left branch. All right, now this turnaround point right here, whose coordinates are 3, -8. Okay, this has a special name. This is what's known as the vertex of the parabola. And part C says find the coordinates of the vertex. Well, there you go, 3, -8. And then I should have written this in a more leading way. I just say, well, what do you notice? I think there's probably lots of possible responses to that question, but the thing I'm really uh, aiming at here is that if I look back at part A, right, the zeros of the function, well, these are the x-coordinates of the points where our curve crosses the x-axis. So in other words, these 2 points right here, right, have their x-coordinates equal to the zeros of the function. So 1, 0, and 5, 0. And so now looking at the zeros here and the vertex here, I can see, right, the x-coordinate of the vertex, which is 3, is right smack dab in the middle of the zeros. Or put another way, right, it's the midpoint of the zeros. Okay, so make a little comment here. Say the x-coordinate of the vertex is the midpoint of the zeros. Okay, it's right smack dab in the middle. You could also say it's the average of the zeros. So if I take the numbers 1 and 5 and average them, so 1 plus 5 is 6. If I divide that by 2, I will get 3, right, which is the x-coordinate of the vertex. All right, well, that's a good place to stop for this question. We'll pick up with more of this stuff on graphing quadratics in question 9 in the next video. See you there.